Today's talk will be about zone block devices. Not sure how many actually looked closely into this technology. So what I'm planning to do, I'm planning to give a brief overview, and then we'll talk about some support on different layers in the data path and out of data path as well. So, and finally, we'll look at some newer applications that are of zone block devices that are related to NVMe. So this is the simplified zone block device model. So we have a LBA range right here. So the concept is pretty simple. So the whole LBA range is divided by larger zones. So they're much larger than the block size as well. So, and they're all the same, of the same size. So the I/O patterns changes in this certain way. It's for read, it's all the same. So just these blocks can be read in exactly the same manner as the usual device. But for writes, so the writes can be only sequential within each and every zone. For that, there's a logical pointer that is introduced for every zone called write pointer. And so initially the zone is empty, and then the host software can start writing, and eventually the zone will get full. And at that point, the write pointer can be reset, erasing the data, and then the zone can be rewritten. So that's a pretty simple concept, but why is it needed? So apparently there has to be some hardware limitations or hardware implications, and yes, that's true. The initial need for introducing that zone block device model was appearance of single magnetic recording and hard drives. So what is that? So the majority of the disks that are on the market right now, they use so-called parallel magnetic recording. So see, there's the head actually writes a bunch of bits at a time. So it could be like several hundred bits here. And what it does, it actually allows to introduce error correction across those bits. And this allows to significantly boost the areal density and the capacity of the drive. So that's this is with the introduction of this technology actually about 10 years ago. The hard drives were able to cross the 1 terabyte barrier, which sounds tiny now. So if you notice, there are some pretty large gaps between those tracks, and that of course affects the total drive capacity. So the reason is that there is the edge field from the right head. You know that, like in physics school course, we have like a bar magnet, and there is some edge magnetic field around. So that doesn't allow to place the tracks closer. But single magnetic recording, it actually tries to overcome this deficiency by widening the head and it's introducing additional error correction bits. So it's possible to place the tracks like that, but there is a catch. So there's only certain order in which these tracks can be recorded this way, and they pretty much see if you look at this particular track, it cannot be if the write is actually placed here, it will be destroyed. But with this order, it is able to work. So that's how this sequential constraint actually occurs. So so if this type of recording would be applied to the entire drive, it would be all sequential, right? So we don't want to do that. So instead, the whole disk the capacity was divided to zones. So within every zone, there's the user single magnetic recording, and then there's usual gap here. So that's how it occurs. And some of the zones on the drive can actually be completely conventional. That looks like this. So you might be wondering if controller can actually hide all these limitations, because, for example, SSDs they write sequentially, but create appearance of the randomly accessed device. Yes, it can be done, but again, with this, the controller would have to actually look like a SSD control, which much more complicated and costly. So as the result of these considerations, there were several models were introduced. Like drive managed model that looks like exactly like a regular disk. So we won't be talking about this. Host managed model that directly exposes all these zone write constraints. And host aware, it's kind of in between. So it can work as drive managed drive, but it's claimed that this host aware drive that it can be optimized if it works similar to host managed. So it can do both. But again, so the host aware model is it was tried and those disks were produced, but they had some not very favorable latency characteristics, and they're most costly. And the majority of the drives that produced now with zone devices, they're host managed. So the next question is, does anyone use this stuff? So it's it looks kind of cool, but so let me just give a couple of points here. Those are taken from official documents. So of course, desktop hard drives market is declining, but enterprise market is growing in double digits, and by 2023, half of the HDDs will be host managed SMR by capacity. So it's a lot of hard drives, right? And it's not just Western Digital; it's all our competitors. They also project similar numbers for growth. So that wouldn't be possible in the absence of standards. And the technology is already standardized. So there's the T10 for SCSI and T13 for ATA, and there's also additional standard. There's a little timeline here. So these standards are initial iteration is already done in the work in progress on the second generation of the standards, and some additional ones are considered actually too. So okay, so what's really in the standard? What's standardized? So far in our simplified model, we've seen that there might be additional operation needed to reset the write pointer, right? Yeah, just a little bit more needs to be added, because there needs to be a command to report zone information. It could be either a device log for SATA or report zones new command introduced for SCSI. And also need functionality for doing some resource management, because again, the point of this not to make controller as complicated as an SSD controller. So there's some strict resource management, and for that there's a notion of active and open zones. So basically, when the zone is opened, the write pointer is copied from non-volatile memory to RAM, anticipating that there will be I/O, write I/O going So this is the state diagram that is taken from the standard. So initially the zone is empty, and it can be either implicitly or explicitly opened. So implicitly opened, it's just by doing a write to the zone. It goes to open state. And then it can be closed, or it can become full. So at that point, we can just reset the write pointer and goes back to empty. So there are some zone operation: open, close, finish zone. Finish zone goes, just moves the zone to full state. And of course, reset zone, we already know that it's necessary. And actually, there's not, for application, it's not necessary to use these three operations, because if we do implicitly opened, implicit open, just by doing I/O, there's another option, there's auto closed. So there's, after max open zones were opened, the hard drive will automatically move some of the zones like an LRU manner, right? They will go to closed state. And so that's how it operates. I think it's pretty simple. So this is the big picture of what is required to support zone block devices in the kernel and anywhere in the data path. So the application, sorry. At the application level, we have some system application that will look file systems, then the device mapper, and at the core there's kernel support at the block layer and schedule, and as well as SCSI. So this is the timeline of how kernel support for zone block device was developed. So the major divide, as you can see, this kernel version 4.10, where the bulk of the API and zone support features were introduced. And just it looks kind of complicated, but the point of this slide is, like, before 4.10, it's only possible to use SCSI pass-through to control zone device. After that, there is some support for from the kernel, actually, which we're going to look at in the moment. Yeah, that's a more detailed overview. See that milestone for 4.10. Before that, there was some support added earlier. But another major milestone was in 4.16. And at that point, the initial code was located in this SD driver. And it was not ideal solution, because many checks for zone devices, they were in hot path. So they were also checked for non-block devices. So eventually, the code that would support a zone block device was moved to a I/O scheduler, and SCSI MQ multi-queue support was added. So in 5.0, the legacy code that was introduced here, it was removed. So now it's all multi-queue. So what does this block support about in the kernel? So this is the main point. Sequential write constraint is exposed to the user. So it means that host software needs to use the direct I/O and always write sequentially. So it doesn't hide the zone constraint for writes. So how it's done? It's the per zone queue depth is limited to 1. So now it's in device scheduler. So why is it in there? So yeah, I was asked maybe why didn't kernel developers just write a separate schedule or maybe reuse some other popular schedule like CFQ. Actually, the code is in a deadline schedule. It's very favorable and it fits almost ideally for block zone device support. And as you can see that like only a tiny portion of that code is dedicated to that. So that thing that locks every zone and maintains the queue depth 1. So one thing that is okay, we limiting queue depth to 1, and how about performance? What's the performance implications? Well, yes, it's recommended that it should be just one writer per zone, but nothing prevents the application to write to multiple zones simultaneously. And if this happens, it's easy. We can easily reach the total write throughput of the drive this way. So there's with the right workload, it's not really a limitation, but it might be a little bit worse for SSDs, which we're going to talk a little bit later. Okay, and this is the part of the block kernel support. There's several ioctls that are introduced. Report zone, reset zone, and if you notice, there are some operations that are not included yet in the kernel support, like open finish zone. And this is this is what happens when the device actually is hot plugged or during boot attached to the system. See, there's pretty common demessage contents that we see here, except there's some differences. If it's a zone drive, it's the direct ZBC or yeah. So, and there's host managed zone block devices, and also it shows how many zones of which size. And once we see it in the log, we can also check the sysfs for these entries and see there's a queue zoned under this device. It says host managed. On your laptop, if you take a look what it says for your boot drive, it will be none. So for here it could be also host aware. And here's number of zones. And see somehow chunk sectors. Why not zone size? It's interesting because chunk sectors are actually a concept predates the like introduction of zone devices. The setting originally was introduced for MD, I think MD RAID, and what it does, if this chunk granularity is divided. Is defined, the schedule will always, if the I/O crosses chunk boundary, it will actually it will not allow it to split the I/O. So the side effect of this, the kernel will actually, for reads, it will never read across the zone boundary, even though it's in theory it's allowed. Okay, so yeah, moving on to to DM layer, zone devices are supported in several components there. DM linear can be chunk aligned, that's one thing, and also the DM zone actually. So if you like buy a drive on eBay and it's by mistake it turns out to be zoned, so you can just run this device DM zone device mapper, and on top of that you can mount any file system. and there's some additional devices for testing as well. So you might be wondering what file systems you can actually mount, without using the DM zone that I just mentioned. And I would say it's a lot of file systems here. So F2FS was originally right from the introduction of this zone block device support. It's supported and continues to support. It works really well. So, because that happened because it's a log structured file system, and it's actually a really good fit for these patterns that go with the zone block devices. Then very recently, the Zoned FS was introduced, and conceptually it works like every zone is exported as a device. Initially, it's like 0 size, and it's possible to write to this device up to zone size. So it sounds like nothing very useful, but instead it's useful for applications like RocksDB or LevelDB. So this can be mapped to what do they call it? SS table. So there's simple user space driver that is needed just to run RocksDB on top of zone device with this. And the Btrfs is support for that is almost ready, so that's being tested. So in near future we'll get that. So, but others, ext4, it's not going to be supported. So XFS, maybe, yeah, we'll see. It's a design phase. It's a little bit more difficult to do it in XFS, but still doable. Okay. So what about system applications? So this is the SG utils can be used because they have report zone, reset write pointer, and other zone commands there. There's command for that. That's stuff. If nothing else is available, that it will work. And if for some unlucky people who needs to support the Windows clients, it will work, and MNGW, it's included there. So for the rest of us, there's an access library called libzbc, which is also maintained by our group, that provides a unified API for across the different access levels, like SG pass-through and block device. So let's take a look at this, maybe a little bit more in depth. So this is the block diagram of libzbc. So there are some block drivers that uses those block IOCTLs that I showed a few slides ago, and then ZBC and ZAC. So this library actually is able to send not only SCSI pass-through but also ATA pass-through commands. And there's emulator as well included. So this is how the what backend drivers it chooses. First of all, programmatically, you can just set some flags. In the command tools, you can specify SG node instead of block device node, and then if you specify block device, it will open the block backend and so on. Okay, and also there is a test suite, and this set of tests is actually pretty important because all the disks, all the zone devices on the market, they're supposed to pass this test. If you get interested and you buy a device and it fails this, so it must be something, most likely with the firmware, either in HBA or in the drive itself. You need to contact the manufacturer, because for all the drives, all the manufacturers actually agreed to comply to this test. There are protocol compliance tests, as well as it's also libzbc included some command line tools that. And a GUI. So it's It's possible to visualize also. All these are some buttons to press to change the zone state. So sometimes it's convenient. So. Okay, so what else is with the terms of systems application? Okay, there's a part of sysutils that's called BVLK zone. It's just basically a simple command that can do these two IOCTLs that are supported in the kernel currently. So zone reports and zone reset. And the emulator. So no one has to have a zone hardware to actually get their feet wet. So there's emulator actually works pretty well. It's based on TCM user. So basically just I don't know if you're familiar. That component allows to create user space handlers for block devices created by LIO. So there's a bunch of handlers there for Ceph and all the stuff. And there's also a handler for right now it's only for ZBC devices, but in the future might be ZAC support is added. So okay, so our favorite benchmarking tool, FIO. About 1 year ago, Bart Van Asch actually added support for zone block devices. And it's, yeah, basically there are three things that needs to be done to make it work. Zone mode ZBD, and it should be direct. Yeah, so, and one needs to set the zone size. Where is that? Oh, maybe. Okay, so anyway, so there's support, and there's also a bunch of tests. They're also available, about 50 tests for this. Okay, so I don't have a lot of time, but let's talk about ZNS, which is zone namespaces for NVMe. So why do this? So the reason for doing this for SSDs, it's completely different. So if you look at the controller, it has a highly parallel architecture with the a bunch of dice, like 100 dice, and the controller is kind of complicated. It does all this stuff that includes wear leveling, bad block management, and garbage collection, actually. And the important that it's to remind you, the flash can only be erased and erase blocks about 1 meg in size. So it's not. It can be erased at the like word or byte granularity. So what happens with the garbage collection, actually? So internally, the SSD controller writes sequentially, but then some rewrites happen, and maybe discard comes, and some data is invalidated, and eventually what happens is fragmentation on the blocks, and in order to free up blocks that needs to be erased, some data needs to be moved, and it creates internal amplification. So it's pretty bad, because right now in modern drives up to 30% of capacity is actually over provisioned. So just by changing the I/O pattern, just doing sequential zone pattern and mapping erase block to the zone, it changes a lot, actually. So it almost eliminates the garbage collection. So consequently, there is no need to this amount of over provisioning, and there's lots of other benefits. So that's basically the key idea about zone namespaces. So, and the proposal is already in works in NVMe workgroup. It's headed by Matthias Björling, who needs to I need to say thanks for this, for a few slides here. So what is different? It's mostly like host managed drives. There are several features. If I have time, I can show you. Yeah, so this pretty much all the same, except zone size and capacity. Writable capacity can be less than zone size. Which allows a lot of flexibility with SSDs. Also, zone descriptors. So zone descriptors can be added and open to every zone. And this is basically just adding some UUID to a zone, and it has lots of use cases. You can just timestamp the zone, or maybe put the data keys there. And once the zone is reset, the descriptor is gone. So. Okay, so I mentioned the implications of the QDepth one for HDDs. So here's a little bit of benchmark that we added. So this is one zone IO, the yellow one, with one writer, 2 or 3. So you can see once you jump to more than one writer, performance actually decreases. So with 4 zones, it scales. It scales, but it scales in not linear manner. So what is being introduced is the zone append, a new command, when actually clients write to this zone start, and the command actually returns the LBA at which within the zone the data was written. And that actually great because it eliminates all need for locking the zone. And with this, the performance actually goes way up. So that scales pretty nicely. And that will be one of the key features of ZNS. And it just slide shows that it maps really nicely in the existing ecosystem that we actually have taken a look early in this presentation. So instead of libzbc, there will be libzns. And see this similar slide, but here there's the screenshot from the emulator. Now it's not SD device, SSD device, but NVMe namespace. And just to show a few slides here. So this is from libzbc, just to compare. So this ZBC report zones with zone device, the SSD device. It works through the block driver here. And here you can see the zone report. Some of the zones conventional, and this is closed zones, and these are, see, these are implicitly open zones, just zones that were written to. Another slide is the same, pretty much, but with SG node, and now it works through a different SCSI driver. And similar with for ZNS, just to show you how it closely matches. So now, see, it's already not SD drive, but NVMe namespace, and this is the libzns interface. It shows the zone report, and you can see one of the zones is opened. And this is the continuation. So see, I closed the zone here in one of it's the same zone, I think. Yeah, and now it's closed. So that's pretty much how it works. So this is what I was planning to talk about. So for what's happening now. So the big topic is ZNS, and we're currently working on this in our group. And like I said, native support for Btrfs is coming. And for XFS, if anyone could tackle this, it would be probably Christoph Helwig, but he has a lot of stuff on his plate, so there's no timeline for this. Some improvements for DM zone and some more tests, of course. So that's what they're working on right now. And okay, so there are some links, but the first link actually is the one that goes to the website that maintained by our group, and everything that I told you, it's probably almost everything is there. So go there if you're interested. Get the script to set up a tcmu-runner emulator. Download libzbc and run the tests and see how it works. It should take like maybe half an hour to do that. Yeah. Okay, so.
Thank you. Okay, so now we have time for questions. This is the first one.
Thank you for presentation. And the question, if you use the DM-Zoned driver, do you still need support from file system level?
No, you can actually, that's the beauty of DM-Zoned. You can mount any file system. You can mount ext4. It will work. So in fact, that's a use case that I just mentioned about running. You can go to that website, set up tcmu-runner, and instead of running libzbc, you can just set it up in the DM-Zoned, format ext4, and enjoy. So.
Thank you. Next question. In addition to first questions, why you still need native support for file system?
Native support in meaning what?
XFS file system native support.
Okay. So why not? The way I understand, why not just use DM-Zoned, right? Because DM-Zoned it works pretty well, but it's not ideal because it also has garbage collection inside. And one thing I didn't mention, it actually requires some conventional zones to be on the drive, which is not a problem with HDD, because in those HDDs on the market, there are in the very beginning there's several conventional zones for the purposes of booting and some other reasons. So DM-Zoned actually uses those. But for ZNS, for example, it's not going to have conventional zones. So the DM-Zoned will have to be patched for that to provide support. And performance-wise, it will work. But if you try just to load almost all the zones, there might be a bit of slowdown from X-series, just because garbage collection just becomes more intense. So but it still works okay.
Thank you. The next question.
Could you share your impression? It will be more frequent to use zone block devices with applications, like with some database based on RocksDB, or it's more suitable for file systems? What, as an end user, what service I will use? Is it something like S3, or is it something like file system for many small files?
See, as the native support grows, it's possible for every user to use them. But yeah, I would say that the bulk of our customers, there are hyperscalers with this block devices. So if you sync your picture on your phone to the cloud, there's like a good chance that it goes to one of those devices. For those customers, they use their custom infrastructure to maintain this. Some use libzbc, some use their own homegrown tools, but I would say yes for those all these Userspace file systems, like you mentioned, like RocksDB, LevelDB, all those Cassandras of the world. All this chunk concepts, it actually exists in so many Userspace file system, and it matches really nicely to the zone model. So I would expect these applications to grow over time. And we actually have, I actually had slides to RocksDB demo, but it just didn't make it to the presentation because of time constraints.
Thank you, and we have time for the last question.
presumably you're only allowed to read from the drive on a zone that's open
Yeah.
between the beginning of the zone and where the right pointer is. You can read after that. That's a question.
Yes, you can, but yeah, it's an excellent question, actually.
So if you, yeah, it's in the terms of security race that I'm asking this.
Yes, there's basically how it works. There is in a standard, there's a bit defined that's called URS WRZ. You don't have to remember this. Yeah, unrestricted write. It controls that if whether application can read above the right pointer or not. So I'll tell you that all the drives that are currently on the market, they have unrestricted reads. So it means that there will be read above the right pointer, and what they get is the predefined pattern, which is usually zeros, right? Yeah, so that's how it works.
Okay, thank you. And what was the best question?
I guess that one is about the unrestricted read.
Okay. Yeah, so do you want another one or a cup?
Oh, okay, I'll take another one. I thought you were going to select another question.
Okay.
I still can. Yeah.
And another question. Another best question.
Yeah, that's that one about the applications about to RocksDB and stuff.
Okay.
Yeah.
Thank you very much. Thank you.
Sure.